Hello and welcome to a new lesson on Docker images. In this lesson, we are diving into the world of Docker images. Think of Docker images as a blueprint for your Docker containers. They are the foundation on which containers are built, allowing us to package our applications and their environments into a neat, transportable format. In this lesson, we are going to explore how to find, pull, build, and manage Docker images from Docker Hub and other registries. We will also unravel the concept of layers in Docker images, discuss strategies to minimize image size, and share best practices for image building. Let's get started. The first step in working with Docker images is knowing how to find and download them. Docker Hub is the largest library and community for container images. You can go to Docker Hub from this URL, hub.docker.com, and you can search here for any Docker image. For example, let me type Ubuntu, and as you can see, you will get the result for all Ubuntu images. Here you can know that this is the official image from Ubuntu. Click the image name, and here you can find how to pull the Ubuntu image using Docker pull Ubuntu. Also, you can pull images based on its tags. So here, this is the latest Ubuntu, and as you can see, the command is docker pull Ubuntu 2 latest. If you want to pull a specific tag, you will search for this tag and you will see how to pull this Docker images or this tag Docker image. Let's go back to our terminal. To download an image, we use the docker pull command. Then we provide the image name. So you can provide the Ubuntu and it will pull automatically the latest Ubuntu image. Or you can provide the tag by 2 dots, then latest. So this command pulls the latest Ubuntu image from Docker Hub. Simple, right? You can search for images as we saw together on Docker Hub or by using the Docker search command. Let's press enter to pull the image. And right now we have the Ubuntu latest image on my local machine. I can verify that by typing docker images. And as you can see, I have the Ubuntu image with the latest tag. And here is the image ID, and the size of image is 77.9 megabytes. As I mentioned, you can search for an image using the docker search command. So let's type docker search Ubuntu, for example, and you will get all the images related to the Ubuntu. And from the list, you can know that if this image is the official image or not by finding the OK beside the image. So OK means that this image is official. Now let's talk about creating your own Docker images using a Docker file. A Docker file is a simple text file that contains a list of commands that Docker uses to build an image. So first, let's create the Docker file. So I will type touch docker file, and here we have our Docker file. Let's learn some of the basic commands you need to know. So let's start with the from command. This initializes a new build stage and sets the base image for subsequent instructions. Then we have run command, which executes commands in a new layer on top of the current image and commits the results. Then we have copy, which copies new files or directories from source and adds them to the file system of the container at the path. Then we have cmd, which provides defaults for an executing container. Based on those instructions, let's write our first Docker file. So here, from Ubuntu latest, and this tells Docker that I will use Ubuntu latest as my base image. Then run apt-get update and apt-get install -y nginx. So this command will update the packages and install the nginx inside our Docker image. Now copy dot. Dot here means that it will copy any files at the same directory as the Docker file inside the images. So I need to copy all files which in the same directory as Docker file to /var/www/html in the Docker image. So let's create an index file here so that we can copy it to the Docker image. So let's type echo hello to Docker course. Then I will redirect that to a file with the name index.html. So here we have our file with the hello to Docker course. Now to the CMD. So I will type the command, then I will explain it. So nginx, -g, daemon of semicolon. So as I mentioned, the CMD instruction in a Docker file provides the default commands and arguments for an executing container. These commands and arguments can be overridden by providing alternative commands when running the container. So let's explain the nginx -g daemon of. So the nginx, this is the main command being executed. In this case, it's starting the nginx server. -g, this option allows you to specify global directives directly on the command line. It's a way to set nginx configuration directives from the command line without modifying the configuration files. Daemon of. Normally, nginx starts as a daemon, a background process. This configuration directive tells nginx to run in the foreground instead. Running in the foreground is a preferred mode in Docker containers. So let's go back to our Docker file. This Docker file creates a custom image based on Ubuntu with nginx installed and your website's content copied into the correct directory. To build this image, let's execute docker build, then -t to provide a name for this image, and let's type my nginx image to be the name of the image, and dot to tell Docker that the Docker file in the same current directory. Now press enter. And from the output, you can see the instructions you added to the Docker file. So here we have the from Ubuntu latest. We have the run, which updates the packages on the system and install nginx. Then we have the copy instruction. We didn't get any error message, which is a good sign. Let's verify that our image has been created. So let's execute docker images. And as you can see, my nginx image has been created, and it was created about a minute ago, and the size of this image is 183 megabyte. Let's verify our work by running the container with port forwarding. We will talk about port forwarding in future lessons. For now, let's execute docker run to run the container, then -d to run the container in detached mode, then -p for port forwarding, then 8080 2.80. So here I am telling Docker to expose the port 8080 so that I can browse the web server inside the running container from my local host. So it will forward 8080 on my local host to port 80, which on Docker container. Then I need to provide the image I will run the container from, and the image is my -nginx-image. You also can provide the image ID here instead of the image name. Now press enter. As you can see, I get the container ID. To verify my work and to list the running containers, let's execute docker ps. And from the output, you can see that I have a container with the ID C42, and this container running from my -nginx-image. And here is the command we added to the Docker file. And this container created 44 seconds ago, and it's up 43 seconds ago. And also it shows that this container has port forwarding 8080 to port 80. Now let's bring our web browser and let's type here localhost 8080. And as you can see, we have the statement from the index file we have created and copied to the container. Hello to Docker course. Image size matters. Smaller images are faster to pull, build, and deploy. Here are some strategies to minimize your Docker image size. Use multi-stage builds. This allows you to use one image for building your application and a smaller final image for deployment. Remove unnecessary packages. After installing packages necessary for your build, remove cache and unnecessary packages. Let us see how we can do that. So let's first create a multi-stage directory. And let's create our Docker file inside the multi-stage directory. So I will use touch Docker file or touch multi-stage then / Docker file. Now let's edit our Docker file inside the multi-stage directory. And first we begin with our build stage. This stage uses Ubuntu latest as the base image. We choose Ubuntu for its wide support and ease of installing packages. So let's type from Ubuntu latest, then as builder. Next, we update the package lists and install Nginx as we did with our previous Docker file. So let me copy the command here. So I'm telling Docker file to run apt-get update and apt-get install Nginx. Now let's copy our project files into the /var/www/html directory as we did with our previous Docker file. Now moving on to the production stage. So let me add comment here that this is the build stage and this is the production stage. So moving on to our production stage, we switch our base image to Nginx Alpine. Alpine Linux is known for its small size and security, making it an excellent choice for production environments. So let's switch to Nginx Alpine. In the next step, we will copy the static content we prepared in the build stage from /var/www/html to /user/share/nginx-html. This is the default location where the Nginx Alpine image serves content from. So let's add the instruction here, copy from, then from builder, and we want to copy /var/www/html to /user share nginx html. To finish, we specify the command to run nginx as we did with our previous Docker file, so I will paste the command here. Now let's build our image from the Docker file inside multi-stage directory. So I will change directory to multi-stage. Before I build the image, let's execute Docker images. And as you can see, the image that we built from our previous Docker file, my-nginx-image, its size is 183 megabytes. So let's validate that when we use multi-stage to build an image, the image that will be created from this multi-stage Docker file will be smaller in size than my Nginx image. So let's build the image from the multi-stage Docker file. To build an image, I will execute docker build, then -t, and let's give it a name, my Nginx image small, then dot. Now press enter. And as you see from the output, the image has been created successfully. Now let's execute docker images to validate our work. And as you can see, my Nginx image small size is 42.6 megabytes. So it's less in size by nearly 40 megabytes than my Nginx image. That's it for building an image from multi-stage Docker file. In this lesson, we have covered the essentials of working with Docker images, from pulling images from registries to building your custom image with Dockerfile. We also discussed how to minimize image size. Experiment with these concepts and you will be on your way to mastering Docker images. Thank you for watching and see you in the next lesson.